Okay, welcome back. Next up, we're going to take a look at something called the definition of derivative. And the word derivative, you're going to see this a lot, all right? You're going to see the word derivative. You're going to hear that word every day, at least once a day for the entire calculus course. Okay, calculus is based on derivatives. And what is a derivative? It's basically calculating the rate of change. We already did calculate rate of change, but that was between, if you look at the two graphs below, what we did, the average rate of change, we did in the previous section. Okay, we just calculated the slope of a secant line between two separate points on a graph. And that would give us, using our slope formula, that would give us our average rate of change. What we're going to do is we're going to take a look at what is called the instantaneous rate of change, which we can abbreviate as IROC, I-R-O-C. And the instantaneous rate of change is the slope of the tangent line. The tangent line is at 1 point on the curve instead of 2 points, which makes it a little bit more difficult because how do you get the slope of a line when you only have 1 point on the line? How do you do rise over run when it's not 2 points? Gets a little bit more complicated. So we're going to take a look at that today, all right? And of course, what you're going to see here today in these videos for a definition of derivative is you're going to see a longer, more painful way of getting derivatives. But in the big picture, you can use shortcuts 99% of the time. So it's only when you're specifically asked for definition of derivative do you have to take this long way. But we're going to do this right away. We're going to just peel off this Band-Aid very quickly. We're going to get to this, and then we're going to do all the shortcuts a little later in this unit. And even subsequent units coming up, we're going to take a look at some other shortcuts that we can do. So first of all, just to use an example that may compare secant and tangent lines and the rates of change. If you're getting the rate of change between 2 points, think about you driving from Moncton to Fredericton and you are taking a trip for 180 kilometers for 2 hours. Okay, so your average rate of change, if you travel 180 kilometers over 2 hours, then your average speed, your average velocity is 90 kilometers an hour. But that doesn't mean that you're going 90 kilometers per hour for the entire drive. You are probably going 110 or 120. Then you start to get a little comfortable and you start going 130. Then you see a white car in the distance and you say, okay, well, maybe that's the police, so I'm going to slow down. So maybe you go back down to 110. Then there's some construction and you slow down to like 60. Then you pick up your speed again. Then you stop for coffee and you're doing 0 kilometers an hour. So your speed, your velocity is changing all throughout this trip. But your average from Moncton, which is the first point, to Fredericton, which is the second point, is 90 kilometers per hour. That's a secant line. That's the slope of a secant line. All right, 1 point is Moncton, another point is Fredericton. If you look at the tangent line, we're getting the slope or the rate of change at one specific instant in time. So what we're saying for that is if you were driving and you're at some point on your journey between Moncton and Fredericton and you just look at the speedometer at any point in time and it says 100 kilometers per hour, then that is the rate of change. That's the instantaneous rate of change at that one specific time. It's not an average rate of change of all the different speeds that you're doing from two separate points. It is the rate of change at that specific moment. So when you, just to take a look at the things I have above here, you're going to see all these different terms used interchangeably. So you're looking for the exact same thing whenever you're asked for all these things. So you may be asked to find a derivative if it's just a simple like an equation. You may be asked to derive, which is the action of getting a derivative. You may be asked for the slope of the tangent line, which is the instantaneous rate of change, which is a derivative. And of course, there are symbols that are also used, some notation that is used interchangeably. You could be asked for y prime, f prime of x, or dy over dx. And of course, that's really just slope. D is delta, which is change. So the change in y over the change in x. So all these things are used interchangeably, and that's a good thing to note because when you're doing problems over the next, basically over the next few months, you're going to see these things asked in different questions. And whenever you see slope of tangent line or anything about a tangent line or a rate of change, we know we're using definition of derivative. I don't think from this point on we'll really be using average rate of change too much in calculus. Calculus is all about instantaneous rate of changes at one particular moment in time. So in the next video, you're going to take a look at the complicated way of getting a derivative, known as the definition of derivative.